Okay, let's talk through the key on those two examples. So carbon dioxide, carbon in the center. So we know carbon has 4 valence electrons. Helium's the core, 1, 2, 3, 4. We know oxygen has 6 because 1, 2, 3, 4, 5, 6. So I drew 6 dots around an oxygen, 4 around carbon, 6 around oxygen. And again, it doesn't really matter where you put them, if you put them paired or single. It really doesn't matter. All right, so then count up the total number of oxygens. So like we were just saying, carbon has 4, each oxygen has 6, so 2 times 6 is 12, 4 plus 12, 16. Then if we put the carbon in the center and connect the 2 oxygens, and then complete the octet rule for the outer atoms by adding 3 pairs. So oxygen already has 2 in the bond, so 4, 6, 8. Oxygen already has 2 in the bond, 4, 6, 8. Total number of electrons so far, 2, 4, 6, 8, 10, 12, 14, 16. 16 electrons. So keep in mind when I'm counting, each pair of dots is obviously 2, but a line is also 2, right? Because that's a shared pair. So we already have 16. So now when we go to question 5, count the number of electrons you've currently drawn, 16. If it's less than the number calculated before, blah, blah, blah. It's not less than. It's equal to. Okay, so then let's go down to number 6. If the number of electron pairs around the central atom is greater than or equal to, you are equal to 4 pairs and you are finished. Well, it's only 4 electrons, 1, 2 pairs. It's not 4 pairs, it's only 2 pairs. So it's less than 4 pairs. Draw multiple bonds by borrowing electrons. So that's where we get to 2 double bonds on the carbon. So basically you can think of it as borrowing from both of these to make 2 pairs, and you end up with double bonds on both sides. This still uses 16 electrons. We didn't create any new electrons. Only God can create electrons. So we have 2, 4, 6, 8, 10, 12, 14, 16. 16 electrons. And we have 8 electrons on each atom. 2, 4, 6, 8 on oxygen. 2, 4, 6, 8 on carbon. 2, 4, 6, 8 on oxygen. Keep in mind a double bond is 2 pairs, so you could draw it like that. All right, and then the answer for example 3. So again, hopefully you already tried this on your own. H3CO- with carbon in the center. So each hydrogen has 1 electron. Carbon has 4, and oxygen has 6, 2, 4, 6. But I put 7 because the minus is an extra electron. Now I put that on the oxygen, but that's kind of arbitrary. You could put it on the carbon as well. You wouldn't put it on the hydrogen because, well, I guess you could actually. It doesn't matter where you put the extra electron. Okay, so again, all of that is from hydrogen has 1, carbon has 1, 2, 3, 4, oxygen has 1, 2, 3, 4, 5, 6. So you can get it from the periodic table. So if we add up the total, each hydrogen 1, 3 times 1 is 3, carbon 4, oxygen 6. The negative sign is an extra electron, so 1. Add those up, 3 plus 4 plus 6 plus 1 is 14. I told you carbon's in the center, so we'll put that there, connected to hydrogens and oxygen. And then complete the octet rule for the outer atom by adding 3 more pairs. So the outer atom is oxygen in this case, 2, 4, 6. Except hydrogen only gets 1, so we're done with the hydrogens. Then count the total number of electrons. 2, 4, 6, 8, 10, 12, 14. 14 electrons. So again, each line is 2, and then these lone pairs are also 2 because you have the 2 dots. All right, so then we counted. If it's less than the number calculated before, blah, 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 it's not. It's equal. So we're all set there. If the number of electron pairs around the central atom is greater than or equal to 4 pairs. So central atom, 1, 2, 3, 4 pairs. So it's equal to, so we are finished. So that's the structure. All right, so now what you have to do next for practice is do these practice problems on page 103, and I will post the solutions, just a PDF of the solutions.